Hello, and welcome to the lesson on special triangles for the College Tech. What's the learning goal? I can construct and determine the exact value of special angles by applying the values found in the special triangle. Okay, so we are looking at what we call special triangles today. There are two basic special triangles. So if you want to draw yourself your first triangle, it's a right angle triangle. The sides are of equal length, so these two sides are equal length. The only possible triangle that exists for that is a 45-degree triangle. 45-degree triangle. And when you reduce it down to the base value, the mathematicians have said we're going to let this side be 1 and that side be 1 because they're equal. And if you use Pythagorean theorem, so I'll just do it off to the side here quick. We know sides A and B, 1 squared plus 1 squared equals the hypotenuse squared. So 1 squared is 1. So we end up with 2 equals c squared. Take the square root of both sides. End up with root 2. So that means that our special triangle, the 45-degree triangle, so the 45-degree triangle looks like this. Side lengths are 1, 1, and root 2. This is something that you want on your cheat sheet. All right. The second special triangle is what we call the 30-60 triangle. 30-degree, 60-degree triangle. And again, it's a right angle triangle. So draw another right angle triangle, and probably guessed that the angles inside will be 30 degrees and 60 degrees. And mathematicians have again gone through and picked out the lengths, and I'm not going to go through the proof. You can see on the first one, mathematically it works. But we find that our special triangle, the 30-60 triangle, is 1, 2, root 3. The 2 is on the hypotenuse. And again, do I expect you to memorize that? Absolutely not. That's why you have a cheat sheet. So, where's this used, or why are we doing this? Well, special triangles are nice because they can find exact value for us. So, for example, sine 45, if you do the exact value, so we take the 45 as our reference angle. So, we know this is our hypotenuse, this is our opposite, this is our adjacent. Sine is opposite over hypotenuse. It's 1 over root 2. That's the exact value, no decimals. So when you have no decimals, you're dealing with the exact value. If you punch sine of 45 in, so I'm going to do that just for the first one. So sine of 45 is 0.707, 0.707. And if you punch in 1 divided by root 2, you also get 0.707. So they're just triangles that work out in such a way that the fraction's even. So sine of 45 is 1 over root 2. Cos of 45 is adjacent over hypotenuse. So it's the exact same value, 1 over root 2. And finally, tan of 45, opposite over adjacent, 1 over 1. Tan of 45 is 1. So if you use your calculator and punch in tan of 45, it gives you exactly 1. So it's one of our special angles. So there are the 3 special primary trig ratios. With the 30-60 triangle, sine of 30 degrees, again, labeling our triangle. So the 30 degrees is our first one we're going to work with, hypotenuse, opposite, and adjacent. Sine of 30, opposite over hypotenuse, is 1/2. So if you punch in sine of 30, you'll get 0.5. Cos of 30 degrees, adjacent over hypotenuse, is root 3 over 2. And finally, tan of 30 degrees equals opposite over adjacent, so it'd be 1 over root 3. Okay, if you do the other ones, sine of 60, cos of 60, tan of 60. You don't have to memorize these. Remember that you're going to have a cheat sheet, right? If we change our reference angle to the 60, this now becomes opposite. This is adjacent. And what you find is that the fractions remain the same. It's just they're equal to different values, or associated with a different trig function. So there are your exact angles with the special triangles. All right. So determine the exact value of the following. So the example I have here, if you have sine 45 and you multiply cos of 60 and you multiply tan of 30, what's the exact value? All right. So I'm going to recreate the special triangles on this page so I have something to look at and point at. So with those special triangles, I can now answer my question. So I want to replace sine 45 with the exact value. Sine 45 is opposite over hypotenuse. So this is going to be 1 over root 2. Cos of 60, if 60 is my reference angle, that's my adjacent, that's my hypotenuse. So cos 60 is equal to 1/2. And then tan 30, I'll just change colors here for a second. 30 is my reference angle. Tan is opposite over adjacent. So that would be replaced with 1 over root 3. So there's the exact value for that expression. Remember, when you're multiplying fractions, you multiply your top numbers together. So 1 times 1 times 1 would be 1 on top. Multiply your bottom numbers together, so you end up with 2 times root 2 times root 3. And that's where you leave it. Okay, exact value means no calculator. So whenever you see exact value, you know you're going to have no decimals in your answer, and you're just going to leave it like that. One more quick example then. So this time we'll do tan of 45 multiplied by sine of 30 multiplied by cos of 30. And I can put as many expressions as I want in here, but all you're doing is simply replacing each trig function with its appropriate ratio. That's it, or fraction. So tan of 45. So going back to my picture up above, tan is opposite over adjacent. So tan of 45 is just 1. What's sine of 30? So 30 is my green over here, so I'm working over with that triangle. So sine is opposite over hypotenuse. So it's going to be 1/2. And cos of 30 degrees, again with the green, cos would be your adjacent over your hypotenuse. Root 3 over 2. Multiply the fractions together. Again, you multiply across the top. 1 times 1 times root 3. So it's root 3. On the bottom, 1 times 2 times 2 is 4. That's it. That's the final answer right there. So you just leave it at that point. Don't go any further. All right, other special triangles. We can make other special triangles if you use the Pythagorean theorem, for example. So for example, 3, 4, 5 is what we call the carpenter's triangle. Carpenter's triangle. So when carpenters are making right angles or making sure corners of houses are at right angles, they measure one direction down the wall, 3 feet, measure down the other wall, 4 feet, and when they measure from those marks, it should be 5 feet, and they know that they have a right angle. Okay? Helps them double check to make sure the square remains the same. This is technically a a special triangle. So why is it considered a special triangle? Well, it's, like I said, 3, 4, 5, the sides work out fine, or even, I should say. They're whole numbers. Are the angles anything special? If you go through and calculate this angle in that corner with the calculator, you end up with, something that's not very nice. So for example, this angle down here, it's like 71 points, so let's call it 71.6, which means that the angle up top, so 18.4. So you can see that it's not, sorry, that should be 53 degrees. I was wondering, it looked a little large, so 53.1 degrees. Well, when has it ever come up that you need to know 53 degrees, and the other one would be 36.9? So it's only special because the sides work out to be 3, 4, 5. So technically, that being said, every triangle could be a special triangle. So for example, construct a special triangle. Oops. With primary trig ratios. All right, so I'm just going to make up a triangle here. And you can see that you can really make it up any triangle into a special triangle. So for example, let's construct it. I'm going to make this side, keeping the numbers even. Let's go with 2 and 5. All right, so to find the missing side, to find the hypotenuse, a squared plus b squared equals c squared. So I would have 2 squared plus 5 squared equals c squared. 4 plus 25. So c squared equals 29. So c would equal root 29. And if I don't use the calculator, I don't end up with a decimal. So there's a special triangle technically. And if I choose this angle in the bottom left corner as my angle of reference, then the special angles would be sine theta. So this is hypotenuse, I've already labeled. This would be opposite and adjacent. So my primary trig ratios would say sine theta equals 5 over root 29. Exact value. Cos theta, adjacent over hypotenuse, would be 2 over root 29. And finally, tan theta would equal opposite over adjacent, so 5 over 2. So there you go. We made our own special triangle. So like I said, the difference between the ones I just talked about on the previous page, your 45 and 30-60 triangle, the angles are nice to work with and the sides are relatively nice to work with. But technically you can go through and then create, using any length of side, create a special triangle. So I have a very, very short example to finish up with. So there is one more video with this, but it will be short, I promise, and then you can move along into the work.